A force is a push or a pull that acts on an object. How many forces can you name? Normal contact force, tension, friction, air resistance, magnetic force, electrostatic force, and gravitational force. In this video, we will learn how we can use free body and vector diagrams to describe forces. Forces are vector quantities because they have both magnitude and direction, and so can be represented by an arrow. Scalar quantities have only magnitude and no direction. When several forces act on an object, they can be replaced by a single force that has the same effect. This single force is called the resultant force. For example, look at this car. There is a force of 10 newtons pushing it backwards and a force of 30 newtons driving it forwards. To work out the resultant force, we subtract the smaller force from the larger force. So, the resultant force is equal to 30 newtons minus 10 newtons, which is 20 newtons forwards, which means the car will be accelerating. This parachutist is falling through the air at a constant velocity, also known as terminal velocity. There is a force of 800 newtons acting downwards on the parachutist. This is the parachutist's weight, or the force due to gravity. At the same time, the parachutist experiences an upward force of 800 newtons due to air resistance. These forces are balanced, so she will be falling at a constant velocity. We can also draw these force diagrams without showing you the object involved. These are called free body diagrams. For example, here is a free body diagram of the forces acting on the parachutist. In a free body diagram, the object is shown as a point. The forces are drawn as arrows starting at the point. The length of the arrow indicates the magnitude of the force, and the direction of the arrow shows the direction of the force. Here is a free body diagram for an aeroplane traveling at a constant velocity and a constant altitude. The weight of the aeroplane is acting downwards towards the earth. The force of lift acts upwards. The plane is traveling at a constant altitude. So the magnitude of the lift and weight forces must be equal. The force of thrust pushes the aeroplane forwards. The force of drag or air resistant acts in the opposite direction. But the plane is traveling at a constant velocity, so the magnitude of the drag and thrust forces must be equal. Scale or vector diagrams show forces acting on an object and the angle between them. They can be used to calculate the resultant force. We draw scale diagrams using the following steps. Step 1. Draw the arrows at the correct angles to represent the forces. Step 2. Draw lines to make a parallelogram. Step 3. Measure the diagonal of the parallelogram. This is your resultant force. Here's an example. A person is running with a force of 10 newtons. However, the strong winds are pushing her with a magnitude of 8 newtons. The angle between her and the wind is 30 degrees. Find the resultant force acting on the runner. Step 1. Decide on sensible units. 1 centimeter is equal to 1 newton. Draw the first force. Step 2. Draw the second force at the correct angle. Step 3. Connect the lines by drawing a parallelogram. Step 4. Measure the line from the start to the opposite corner. Use your scale to work out the magnitude of the force. For example, 17.5 centimeters is equal to 17.5 newtons resultant force. So that's how we can use free body and vector diagrams to describe forces.